right, Kenny, keep going.
We had just started this experiment at the moment, and here we go. We are looking at from a.
We forgot to record 10 minutes. Once we'll talk about what we did. Keep going.
It's more. Oh, well, we can go any higher, but don't you think it's like already turning into a gas?
No, go higher.
I think it's about the point where it's changing over, right? Yeah. About changing. What temperature are we at right now?
108 Kelvin.
108.
109.
Go 109. Try one more.
There you go. Beautiful.
We can go. Let's try a little bit more. See what
Yeah, we
happens.
can still go a little more because it's still under the phase change process.
112.
Higher, higher.
115.
112. Can you get a even number? Oh yeah.
Oh, I think it's at this clump right. This is clump right here. I don't know. Like.
Oh, keep going a little
Come
higher.
on, Kenny.
Okay.
Relax, relax.
Come on.
That's definitely a gas. That's a gas.
I like that. 145. Yeah.
Alright, but we gotta find where it starts to change, and that was around what, 115?
Yeah.
Okay, so 115 is gonna be our limit for this one. So it's gonna be a solid from, what was the other number?
Yeah, like right here.
91 to 115, it'll be a solid.
Right here. Yeah.
And then from 115 forever, it's gonna be a gas. Okay, oxygen, last person. Oxygen, who wants to do oxygen? James, you're volunteer, come here.
Fuck crowd. So go up there and dance around from the people looking at you, judging you.
Let's go, crowd. Come on, volunteer here.
Okay, keep going.
Participate or die.
Boo.
I mean, why don't we wait and see what happens? What does that look like?
Hey, that's a liquid, right?
I feel like it's going between the solid liquid right now, right? Now there you're at your liquid, I think. It's starting to flatten out. We want it to really flatten out.
Yeah,
It's probably pathetic.
Yeah, I'd say it's about a liquid now, right? Okay, 104. So our solid is from 0 to 104 there. Our solid is from 0 to 104. All right, James, keep going.
I know I am.
Thank you, sir. 0 to 104. You have to hit the screen, hit your closing player. The bottom one.
Wow.
The bottom. Hit it again. Click the bottom selection. Hit it. Now wait. Now go.
Also, you guys like screaming at him.
Go, James.
Going too slow. James, hurry up, man.
Right.
What are you doing?
They're joking, James.
I'm not.
You're probably better than the keyboard. You're probably better than the screen. The pad is
again. You are terrible.
There.
That pad is really bad.
It's really good once you get used to it.
Oh! I'm sorry that my hand is not deformed, and I have to like.
Miss Goya has 2. Karen has the same computer.
It's not
I
helping the
have
cause.
that.
It's
Same
not
thing.
helping the cause.
You gotta hand this to
I think that's.
A little bit there.
Maybe you're doing
There.
something. I never thought about that.
I'm proud to have a hand deformation on my hands.
No, not yet.
I'm not.
I don't know.
It's still kind of a liquid at the bottom. I go a little hotter, right?
You never wear a
I
ring.
want it to be gas, a little bit more maybe. Okay. That's definitely going higher now. That's good. That's definitely high now. Let's just say 150. 150 for this one.
makes that face he looks like.
All right, and then the gas is 150 to infinity. Thank you, James. All right, so let us fill in our table together real quick. Or I'm going to fill it in with all of you, just so we're all clear. Karen, can you read me your neon, please?
34.
Okay.
I don't know what units that.
Kelvins, thank you. All in kelvins. Temperatures are all in kelvins. Delpho, what do you got for argon?
Argon, I got 0 and 91.
0 to 91. Thank you. Continue.
91 to 115.
And then? Thank you, sir. Tasty, your last one.
I got a 0 to 104, 104 to 150, 150 to 150.
All right. So, part of your lab on your own is going to be the following. Write it down. Research, no, we're going to do some more questions in the back still. But part of what I want you to do is, and it's not on here, that's why, you're going to do it at the bottom over here. You're going to do this work right at the bottom. research what the boiling and melting points are of these three elements.
What?
Neon, argon, oxygen. Find their boiling and melting point and see if they match up.
Oh, the exact.
Again, what do we know? Our melting point of neon would be 28. That's where it changed from solid to a liquid. Our boiling point of neon would be 34. And again, what are my units here? Kelvin. So whenever you look up, you might want to convert to Kelvin. So you're going to have to use the conversion. That's why I'm doing this. You clear? Because chances are you're going to find the boiling point of neon, argon, and oxygen either in Celsius or Fahrenheit first. So you got to use Kelvin though. So convert them. So again, you're listing the boiling. Well, let's do the freezing first. Freezing point of all three, and the boiling point. Freezing and melting are the same. Fusion. Now, what I also want you to do, what I also would like you to do is to also cite your reference. So whatever it turns out to be, cite your source, please. Okay? If you want to use Wikipedia, that's fine. I don't mind for this one. I'm telling you that. But if your teacher does not tell you that, you don't use Wikipedia as a source. So we're all clear on that. Again, if I tell you it's different.
Crystal!
For scientific purposes.
All right.
What if I select somebody?
I'm
Now-
gonna go to Wikipedia and just say what they say.
You gotta guess.
Let's take a look at number 4, please. Let's take a look at number 4. Okay, I skipped number 3. I want you to work on that one on your own. You'll see it's not that difficult. Number 4 says, next choose the substance water. So go to our lab, let's choose water. Okay, I'm going to lower the temperature clearly so that we can start at the bottom. A little faster, come on.
You like it overloaded. You like
So when you lower the temperature.
The reset button works better. Alright, now this is our water molecules, that's why there's the hydrogen bond, you see 3 of them together. What I would like to do is this. We're going to add heat until it turns to liquid and try and figure it out. We know what these points are, right? What should they be? What should the temperature for a liquid to start to form for water be?
0.
0 what?
104.
0, what's it called? Celsius.
Celsius. What should the temperature for a gas to start to form? 100 Celsius.
Yeah, be quiet. Thank you.
We all like your
Stop. I want you yelling at me. Understand? So, 0 is 273, and 100 is 373. Again, you always add 273. All right. Is that left?
No.
There was a full box here last
Oh,
year.
right here. Hold up. Hey,
This guy.
Water. Now,
Why'd you write 370?
because 100 Celsius is 373 Kelvin. Remember, the conversion is to add 273.
Gotcha.
Is it urgent, or can you wait a little?
I need some heat.
Sure for it.
There was not that many in there, okay?
So-
I only used 2. For example.
So what we're going to do is to try and verify this, to actually see if this lab actually works realistically. That was the next part of what I want you to do in the lab. So you did this for argon, neon, and
Water.
oxygen, thank you. And now we're going to check for water. Okay? So again, 100 Celsius and 0 Celsius are boiling and freezing temperatures respectively, which as kelvins are 273 C37. Okay? For water, thank you. Now, what that tells me is that at 273, this should start to turn into a liquid. It's currently a solid. Anybody want to do it?
That looks like
You do.
And then try it?
Yeah, look at that, try.
So that's 256.
No, go to 273.
What do I got to get up to?
273. No, you passed it.
Sorry.
It's okay.
It's very sensitive, this one. Wow. Yeah, you want it? We want to get up to 273 without passing. So maybe like 270 might get to. One pass.
I know.
You You got to actually go to cool to actually reduce it now.
Oh.
Yeah, you can't just reduce the heat. You got to go to the cool.
And you know what's funny? You're still burning it. Even if you heat it up for cold, you're still burning. I'm just saying. You talked about this before.
You're still removing any heat you need. You're not necessarily burning it. Still burning it. It's definitely it's a chemical reaction. All right. What we're noticing is when Karen gets to 269 here, it's still solid, but what do you notice about the molecules now? Aren't they vibrating more? Why are they vibrating more?
They're about to go through a phase change.
Okay, good.
More energy.
More energy stored in them. Heat is being, what did you say? Heat is being applied or added. Heat is being applied, I heard over here. So remember, what was our definition of temperature? What is it? Average kinetic energy. So as Karen increased the temperature, even though a phase change did not undergo, notice, wasn't the kinetic energy, the motion, higher? Aren't the molecules moving faster now? Thus there's more kinetic energy because there was more temperature. Now, at 273,
It's very sensitive.
I was thinking about my feelings, but I didn't care.
I'm not good at this, Karen. You better come back up.
Why don't you use your little keypad?
Karen, why don't you just
Format.
How are you doing that? You're barely moving it?
That was not me. What was that?
No, we skip.
It won't get down to 273 though. Oh, there it is. Okay. So, you notice the molecules are starting to separate. They're starting to separate, and eventually, this, if it stays at this point for a long time, it'll stay as a solid until you surpass the freezing point. Okay? So if you keep adding more heat, it'll then eventually turn to a liquid. And notice, it is slowly turning into a liquid. It's undergoing a phase change right now at the freezing point. And then if I increase the heat even more, and I'll do a lot, I know, now it's clearly going to be a liquid. Because now it's 304, and you can see the shape of it is taking the container shape. Okay? So what are those two values going to be? It was just for you to practice to see what you get. 273 and 373. Okay, again, the minimum temperature it needs to be for a liquid is 273. The minimum temperature for a gas is 373. Both units are kelvins. All right, let's see. Number 5 and 3 you're going to do on your own. Number 6, let's do together. All right, let's click on the phase changes tab now.
Number 4, the Kelvin?
What is this?
Actually, never mind. Got it. I'm sorry.
What the heck? It froze now.
Right here, right?
Yeah, nothing's working, guys.
I can screw that all up.
I don't think it's not going to change though. I'm trying to click on it. Oh, you got to right click. That's odd. There we go. Right click is the other one, Karen. I have to right click to actually click on the tab. But you normally left it.
I don't want to blow it up.
All right. So let's take a look at an example here now.
You don't have to.
In class, we talked about PV over T equals PV over T to find the relationship between pressure and temperature. Does anybody remember or want to raise their hand and reiterate what we know about pressure, temperature, and volume? Give me some facts or some key points. Give me one.
If you raise the pressure,
If you raise the pressure, the temperature increases. Decreases. Very good. Because that's the idea of the condenser and the compressor from yesterday's thermodynamic cycle.
I do that.
If you increase the pressure, if you have a container that's filled with a gas,
They don't have any more books.
if you have a container that's filled with a gas, and I were to have the gas and I were eventually to push down enough, so I kept increasing the pressure, those molecules that were a gas will get close enough that they'll start to condense, and they'll start to actually turn into a liquid. So you're lowering the temperature there. Okay, next. If I add heat to this, what do you think is going to happen to the pressure? It's going to build up, right? Like when you add heat to the pot of water that you're going to boil for macaroni. The top of it starts to shake eventually.
Isn't there when you do the tea thing and whistles?
And the teething whistles because there's so much pressure, it comes out the hole, which causes the sound for the whistle. Okay, it's the pressure that's in there. So watch what happens here. If I increase the heat here, we're going to start to see the molecules move. The temperature changes, right? See the temperature up top here? If I increase it enough,
It's gas.
look at the pressure. Look at the pressure gauge.
Okay?
What's happening to the pressure?
It's up,
Shooting up.
up.
Like a ruler.
It's an atmosphere. See that? The pressure keeps going up. The pressure keeps going up. Now, I stopped adding heat to this. What happened to the pressure? Or just
It's coming back down.
not back down. What is it doing really? It's evening out. It's stabilizing. Okay, again, the pressure kept increasing, and now I stopped adding heat, and the pressure is somewhere between 18 and 20, it looks like, but it's staying there. Now, that's a finger. That's somebody's finger holding it. Now, if we keep increasing the temperature, we're going to keep increasing the pressure. What happens when the pressure in the container exceeds the container's limitation? Blows up. Okay? Let's see if that actually happens here. Forget if it does. Temperature's going up so slow, though. Oh my gosh.
It's realistic, I mean, in a way.
Okay, so what equation
He's a teacher. Good job.
I forgot that, the graph right behind Mr.
He is a
Howell.
teacher.
Oh, you know why? It's because we're on neon.
Oh, my Lanta.
Let's do water. Let's do water. It's on neon, that's why. Sorry. So for water, if we increase the... Yeah, look at the pressure go up.
Yeah. Wow.
Yeah, wow.
Big difference.
Keeps on rising.
It should go up faster.
Oh, yeah.
Well, this is a safe experiment, nothing blows up.
I think it does blow up, actually. That's why I'm trying to do this.
Mr. Howell's gonna
Very hesitant.
Mr. Howell was that little curious kid.
Who designed a bunch of electric shot himself to intelligence.
Nice.
He was like,
Nice.
No, Tom.
The only way that he can get smart is by shocking people. Nice.
Every day he goes to like local utility center.
What is this? Futurama?
So imagine water this hot, hot right now. Okay, it's very, very high temperature. Clearly, this container can withstand a lot of pressure. We're at 145 atmospheres of pressure.
He's in crystal with me.
You know how much pressure's on you right now is 1 atmosphere? Imagine amount of pressure on you being 150 times that amount. That's what's going on inside the container.
Is that what you feel when you're in the airplane?
Come on, it's almost...
Is that what you feel when you're in the airplane?
Mom.
Kaboom!
Oh, it's not gonna blow up, because it's not realistic.
Overload! Oh, there it goes.
That is not what I expected. That just looks like he really...
I know. By the way, I could have also changed the pressure with this pump.
Oh, wow.
That's us.
Wait a
Can I?
minute.
Alright.
No, it's gonna take longer.
Oh, that's actually adding more molecules, it looks like. Oh yeah, that's what this is doing. This is just adding more molecules.
But it's increasing the pressure anyway.
What is it, bubbles?
Yeah, exactly.
Having fun with stuff.
Alright, so, the idea from this problem, sorry. So explain how change in temperature affects the pressure inside the container. So as the temperature goes up, what happens to the pressure?
Yeah. I mean,
Ooh. What did you just see? What happened?
As
As the temperature goes up, the pressure goes up.
that number 5.
Okay, number 6, guys, number 6. And then it says, what equation from class confirms this relationship? What did we say? PV over T, good. PV over T equals PV over T.
Oh, PV, wow, the PV.
What number are we on, guys?
Well, 6, we skipped 5.
All right, we're going to stop there for today. So your assignment for the rest of this lab is the following. Research the temperatures for the bottom here and compare them to what we got.
All right, the way to summary.
Complete number 3, number 5, and number 7. Now, number 5 says remove heat from the solid phase. You don't need to do the lab for that. Okay, you do not need to do the lab for that. Number 5, again, you don't need the program. If you want to, you can use the program. It's on the same website as always, that PHET site. I can post a link to it on Headline and Facebook. But again, number 5, you don't need the lab. You don't need the lab for any of these, or at least the program for the lab. All right, whoever's not here, next, before I get to the calorimetry, which we have 10 minutes left, before that, I want to hand out the egg drop competition requirements because we're getting toward the end of the year. There's only 3 weeks left in school, and it's a really fun competition. I think a lot of people really enjoyed it last year. It counts as like a project grade, so it's going to count as a test grade also. Okay, so we're going to be doing an egg drop. I'm going to hand it out, and we're going to go over this real quick. You're going to be able to, and I'll explain how your groups will work. I'll explain how that works.
My handwriting is awful.
How many times have I told you?
I just go back to
This is Mr. Lee, Mr. Halley, and we're going to do parachutes.
Oh, 8-2.
I know. And I have a picture of it. It's on the restrictions, don't worry. I got these, Sarah.
Why are these so?
Okay, guys, someone's up with the copier. Obviously, you can see that. That's why they're.
Is it the copier?
Nothing I can do about it.
I think it-
Yeah, the copy of the student.
No, the copier. I printed right to the copier.
Oh, we just stayed still.
That's right, you're not the property, it's the problem.
It's the student.
The teacher's
Same kid that's always sitting there, going bad look at his face.
Guys, it's not the student. It's the copier. It's nobody. Now, here's the requirements. Here's the requirements. First, the container. We don't have to do this project, guys. We really don't. But it's going to help a lot of your grades. So I want to go over this so you have time. The container that you build, cannot be bigger than 1 foot by 1 foot by 1 foot. Now, just to give you an example of what that might look like, this is approximately 1 foot by 1 foot by 1 foot. Yes, it is. This is about a rule of length each dimension. This is 1 foot by 1 foot by 1 foot. So if you're going to have an object that's bigger than this, it's not accepted. It's got to be smaller than this.
Can we put pillows in
Okay?
it?
I'm going to have an exact dimension set up so you can come in and test to see if yours fits. Second, you need to listen and then you can ask questions. Second, parachutes and balloons cannot be used. It's the second requirement. It says it right there. Third, on the day of the testing, the container must be able to hold the egg without alterations, which means you can't say like, oh, well, I have an opening to it. You can put the egg in, Mr. Howell, then I have to finish up and close it. You have to be able to receive the egg without making alterations. Is that clear? For example, last year a group tried to do something where they had a shoebox in theirs and they wanted to tape it shut. I said, you can't do that. Now you have to drop it and hope it doesn't open up. You can't have alterations. I need to be able to physically take your project, put the egg in it, and go. Is that clear? You cannot have alterations after I put that egg in.
Gelatin.
Use whatever you want, and it's up to you guys, but I'm just telling you that. Give me a minute, I'll take questions. Write down any questions. Next, the container must make contact with and remain in the designated landing zone. 5 feet by 5 feet. These tiles are 1 feet. So, a 5 foot by 5 foot would be from my right foot all the way to my left foot. That's 5 feet. And then in that direction. And then in that direction. So we're looking at a box. We're looking at a box about this big. Okay? So, it has to remind you, land in and remain in. A lot of groups last year made some crazy cool creative stuff. They dropped it, it landed, but then it bounced out. Okay? You have to land in the zone. Next. The zone is going to be concrete, by the way. But I'm telling you now, last year I told them it could be anything. It was concrete. I'll tell you now it's not. The container will be dropped by the team member. It's going to be two people per team. Okay, by a team member from the outdoor stairwell attached to Samuel Wall. So the top of that stairwell, the very top, is where you're going to drop from. And a group member does it, not me. I'm not dropping because I'm not responsible for it moving left and right. It's up to you to decide where you want to drop. Next, this is good in case you want to practice. That's why I'm telling you this. I will fry the eggs. Easy enough. The eggs will be normal eggs, not jumbo, not extra large, but normal, large-sized eggs. Okay? Because it does affect your container.
It does.
It definitely does. Some people tried to make one that was the exact shape of the egg to hold it last year, but it wasn't big enough or it was too small. I'm telling you now, if you go to Giant, there are eggs that say large, extra large, jumbo. We're going to be using large-sized eggs. You want to write that down? Large. Next, students may work alone or with one partner. Next, 2 designs. I want 2 designs. Not 1, but 2. 2 designs. Sketched out, so you draw me a sketch of it, 3-dimensional or on the computer, whatever you want to do. A sketch of your design and a description. I'm giving you a week, so you have a whole week to do this, okay? Next Tuesday, we'll say. Next Tuesday. Then, a lot of you guys have AP exam Wednesday, Thursday, Friday. So I'm giving you the next weekend to build. So the weekend after AP exams, that Saturday, Sunday, if you want to build and test them, and they're not going to be due, the actual container, until the following Tuesday. The 8th and the 15th are both Tuesdays. And I did that on purpose, because I want you to be able to, well, first of all, you work on the 7th. So that's why that one's the 8th. But for the other one, if you want to bring it in on Monday and show me the container and ask any questions, you're welcome to do that. Okay, so really, you have 2 weeks, 2 weeks from today. Today is the 1st. The actual competition will take place on the 15th. We will do the competition on the 15th. Please listen and then talk, because you're going to ask a question when we get upset. The competition will take place on the 15th. If you would like to, you are allowed to then fix your object if it doesn't work and try again on the 17th. Are you clear? On Thursday, we can try for a second trial, because I want to see that people can actually fix it. So if it doesn't work the first time, you have one chance to remodel or redesign or recreate or just alter something and then try it again on Thursday. So those last 2 days, that's going to be Tuesday and Thursday, we're going to do that. Now, the judging, here's how it's going to work. First place of all. Landing in the zone, unbroken egg, least mass. So your container that you build, I will weigh, or I will mass it in grams. Okay? So if you have the lowest mass, your container stays in the zone, and the egg doesn't break, that's first place automatic. First place 100. Okay, first place egg. The next one, okay, is still going to be unbroken, but the next highest mass. So example, if Karen's is 10 grams and his is 8, his wins, but hers is right behind, because hers didn't break also equally, okay? Now, at the end of that, if you miss the landing zone though, if you miss the landing zone, look at, I put a little schematic here. If you miss the landing zone, but it's not broken, you end up placing after everybody that was unbroken and in the landing zone. Okay? Then after that goes to the next category. You're then automatically lumped down here. If your egg breaks, you're automatically in here. If it breaks and it misses the landing zone, you're last. Because that's the 2 requirements you need to do.
And you get like
Is that clear?
Yeah.
Okay, now, the most creative one, and there'll be other judges. There's about 5 judges we're going to have. The most creative one will automatically receive at least a 90.
Creative meaning
Creative.
colorful.
Just creativity, ingenuity. It can be colorful, it can be creative as far as design, overall creativity. It's going to be judged by other judges, not even me. Okay? So creativity and ingenuity. The number 1 creative one, you'll get a score of 1 to 5 from 5 different judges, so you have a score of 25. The most creative one will have a minimum of 90%. But if yours is the most creative and you win, you get the 100 step.
What if you're
Okay.
the most creative but break?
You get a 90 step.
Okay.
Right? So if you're the most creative, you get a 90, but I wouldn't bank on that, because a lot of people thought theirs was really creative, and then they saw others, they were like, oh my gosh, I didn't think of that. So don't bank on being the most creative, okay? Let's see. That's it, that's all the rules. So, either you're by yourself or with one other partner. It's up to you to decide. I'm not forcing you to pick a group partner. I'm not going to make you do that. You pick on your own if you'd like to. Some people I know, it's busy right now and you're not going to be able to get together, so you might want to work by yourself. Okay? If the person you want to work with is not here, simply ask that person and tell them. Okay, but I do want to know by next Tuesday when you submit your designs, what group you're in. Okay? And please, if I see this happening, and I'm not stupid, I'll know what's happening. If I see somebody make a design, and then on Tuesday morning, John Doe, some person says,
That's a dead person.
I know. John Smith says to Maria, because I don't want to call someone out, so you want me to feel embarrassed. All right, Byron, say you forget to do your project next Tuesday, and Tuesday morning you ask Maria, can I just be in your group, just put my name on it? Okay? I don't want that stuff happening, guys. So please pick your groups before Tuesday. I don't want to hear on Tuesday and Monday that you're picking your groups then, because that just tells me that you're just doing last minute. Okay, you have this whole week to design. So think about it today, talk to other people, okay? Decide who you want to work with. Doesn't matter who. All right, now I'll take questions. Because I know that I might have answered some of you.
Like, Harry has a lot of experience with,
Wings come from.
Guys, wings are not a parachute. Wings are not a parachute.
So we need to use wings.
I get a bag.
Sure, you can absolutely use wings.
At my house. Put a burn.
All guys, all I'm saying is you cannot have a parachute or a balloon. So again, if your parachute is conical, if it's spherical, it's a parachute. It's still a parachute. You can't try and make something that doesn't look like a parachute, but it's. If you have some sort of fabric that slows down its flight on the way down, that's what a parachute is defined as. So don't try and use, technicalities. If you're in doubt, ask. Like you just ask. Can you have wings on it? Sure. You got wings.
Cardboard.
Next.
I don't know, like I thought I heard you say this, but let's say like your, your shell, whatever it is, breaks, but the egg still survives. Does that affect the weight at all?
No. The shell can break. The egg is the person. So if like, say you got into a car accident,
So
your car
they
gets
can get
totaled.
injured.
Your car gets totaled, but you're still okay. Are you happy? That's the idea. You're trying to save the egg. You want to get this to work so that the egg does not break. The egg cannot break. The object itself could break into 10 pieces, but if that egg is still in one piece, no problem at all. Okay? But remember, guys, the egg needs to be in that landing zone. If a part of your object breaks off and it goes out of the zone, but the egg is still in the zone, you're good to go. Okay?
I'm just doing
Okay.
I just thought it was one.
Other questions?
3 people.
No.
Two.
Two.
Two and a
Because I
half.
a lot of problems.
Two and a half.
We'll take a couple.
Well, hi guys.
Well, she could be like,
Right.
we
could be
I want two and a half.
everything has
Two and a half.
Alright, last thing. Last thing, guys. On Thursday, we'll definitely do a calorimetry problem to start, seeing as the period's over now. Okay, we'll then look at a pressure example. We'll look at a temperature change example. So bring all of your stuff that you have, homeworks, notes, all that with you. Also, on Thursday, we're still doing the fundraiser for the cornstarch over at the farmer's market. We're going to do this Thursday and then next Thursday instead because of last Thursday. So if you signed up, I'll put it on Facebook, whoever signed up, and on headline, so you can see. Okay, but on Thursday, be prepared to go over there. Those of you who are on the first shift, right after school, set up from 4 to 5:30. Then at 5:30, I'll probably be over there by then. And the second shift is coming in around 5:30. You guys can do as much research as you want. Absolutely, I have no problem with that at all.
What do we have to ask our research?
Are we because other stuff doesn't grab. I want the idea, I don't want it to like a Lego in there. Is that gonna break?
The Lego would be a good shell.
What about tomatoes?
We bought some Lego tomatoes.
Already. You never know that.
Questions are weak.
Oh, you did? So you traded me. I was
sold out.
Cut it.
Damn.
I sold out. And then
I sold out.
I sold out.
He sold out.
No.
Everybody's happy.
Like, you know, I don't know that it is all racial. It's so hard.
Yeah, Kenny, you should do that and give him curious.
Huh?
Yeah.
Make sure you know if you want.
Yeah, you can put the 5K on.
It's gonna flip, it's not alter. See what I'm saying? If you add P, now additional stuff on.
So you can have like a
I would definitely mess around and see.
No, I
Again, you want the smallest events too.
It's already applied already. You just untape it and do it. That's the count or no?
That's fine. Again, an alteration is something that you've actually done here. The tape you remove and put it back, it's the same thing. Alteration is cheaper.
less.
That's what?
I don't know, think of another way and I could answer your question.